this series. We are starting the first series, which we call Electrons in Solid. And the condensed matter physics and solid state physics. And many people ask, what is the difference between solid state physics and condensed matter physics? It are one and the same, but you should understand the solid state physics is subdivision of the condensed matter physics, because the condensed matter physics includes Bose-Einstein condensed states, He for superfluidity, cold atomic systems, quantum gases, fluids, polymers, colloids. So for students, I can tell it's something like a gel, so which is not hard, and so those things can be brought under the title condensed matter physics. And all those who are rigidly solid can be brought under the title the solid state physics. So condensed matter physics is a broader title, and solid state physics is the subdivision, or it comes under condensed matter physics. So now what we have taken, we have just chosen a small area in condensed matter physics, that is a solid state physics. Under that solid state physics also, it's a vast subject, but it is the subject of interest because people doing research spanning all possible areas, be it robotics, be it machine learning, and be it space technology, be it biomedical application, or medical diagnosis and instrumentation, whatsoever it may be, it all deals with some materials. So material sciences should also be done with a different perception, now with a holistic understanding. So that is possible only if we have a clear or a clarity of the base on which all these research are revolving, which is the solid state physics. And that's the reason we have taken this subject, and we have taken only one small area called electrons in solid. So now the objective of this course is to refresh salient topics in solid state physics and to provide an exposure to understand basic solid state physics concepts behind research. So at the end, by the time we finish all the courses, this time it's not 5, we have made it 6. So by the time we finish 6 sessions on this subject, we will be able to understand how small things we learn, fundamental concepts we learn, are so very important in deciding the promising applications in technology. So that you would be able to appreciate by the end of this series of lectures. So now coming to this, and this is what we have just listed. So we thought, we will go in this particular direction. So first, starting with salient impressions in solid state physics, all the fundamental concepts of bonding in the electron, spin, and reciprocal space, because that is very important. That is the terminology that we are going to use again and again and again in interpretation, or sometimes we don't use them explicitly, but they are the reasons for some of the wonderful observations that we make. So that forms the first part of it, giving clarity in the fundamentals. And the second part, we are going to start with electrons in solid, where how chronologically the ideas evolved in understanding the role played by electrons, because they are the ones who are deciding, they are the ones who govern most of the important properties of solid. And then about bands before getting into density functional theory. Again, if possible, we will have exclusive series for density functional theory, including all functionals. May not be now, but now we are going to do very basic concepts of density functional theory and overall view and applications of density functional theory. That part will be included as the continuation of fundamental theories to understand electrons in solid. So again, I want to tell, I may not be taking in the same sequence as given, but I have just combined. These are the concepts you will be able to listen during the sessions